Dalton's law of partial pressures is something that we need to use when we're dealing with mixtures of gases. So far when we've been talking about pressure, and we've been using the combined gas law and the ideal gas law, we've been talking about a gas that just has one gas in it, so just carbon dioxide, or just hydrogen, or just helium. But that changes if we have a mixture that has more than one type of gas in it. So for example, in this tank on the left, okay, we have argon, hydrogen, and helium gases all in the same tank, all mixed together. So, how do we use the law of partial pressures? Well, the law of partial pressures tells us that the total pressure of a mixture of gases is equal to the sum of the partial pressures of the gases in that mixture. So, for example, let's say the total pressure, P sub T, equals the partial pressure of gas 1 plus the partial pressure of gas 2 plus the partial pressure of gas 3, and on and on and on, depending on how many gases are in the mixture. So in this example down below, okay, let's say the partial pressure of argon is 2 atm. The partial pressure of hydrogen, partial pressure of hydrogen is 3 atm, and the partial pressure of helium is 4 atm. And I just chose these numbers at random. Okay. If we wanted to figure out the total pressure of the gas in the tank, we would just have to add up all of the partial pressures. So in this case, the total pressure would equal 2 plus 3 plus 4, which would equal 9 atm. Okay? So let's apply that knowledge, the law of partial pressures, to a couple other problems. So question 1 reads, a tank filled with two gases has a total pressure of 8 atm. If gas A has a partial pressure of 3 atm, what is the partial pressure of gas B? So let's go ahead and look at our givens. A tank is filled with two gases, has a total pressure of 8 atm. So that's my P sub T, total pressure. Gas A has a partial pressure of 3 atm. So P sub A equals 3 atm. And the problem is asking the unknown, what is the partial pressure of gas B? Well, Dalton's law tells me that the total pressure of a mixture of gases equals the sum of the partial pressures. So in this case, partial pressure of gas A plus partial pressure of gas B. So all I got to do is plug in my numbers. The total pressure is 8. Partial pressure of A is 3. We don't know the partial pressure of B. Solve by subtracting 3 on both sides. So we know the partial pressure of gas B equals 5 atm. Done. Number 2 says 3 gases are combined into a single balloon. Each gas has an individual partial pressure of 4 atm. What is the total pressure of the mixture in the balloon? Well, PT, if there's 3 gases, is equal to the pressure of gas 1 plus the partial pressure of gas 2 plus the partial pressure of gas 3. If I know that each gas has a partial pressure of 4, then this is just 4 plus 4 plus 4. Another way of thinking of that is 4 times 3, which gives you a total pressure of 12 atm. There are 2 problems on this page that I want you to complete for an independent practice. So go ahead and pause the video right now. Once you finish, hit play, and I'll go over the answers so you can check your work. So for number 3, you have 3 gases mixed together. The total pressure is 1 atm. The partial pressures of N2 and O2 are 0.4. So PN2 plus PO2 plus PAR. Oops. So we know the total is 1 equals 0.4 plus 0.4 plus PAR. You solve for PAR, and you get an answer of 0.2 ATM. For number 4, two gases have a total pressure of 8 ATM. If one of the gases has a partial pressure that is 3 times larger than the other, then what is the partial pressure of each? So this is a little trickier, okay? So we know that PT equals PA, partial pressure of A, plus partial pressure of B, okay? And we know that one of these gases is 3 times larger than the other. Well, if we know the total must equal 8, okay, there's a couple options. You could have the partial pressure of 1 be 1 ATM, 1 be 7. You could have 1 be 2, 1 be 6. 3 plus 5 equals 8, or 4 plus 4. So you got to think about, of these options, which one has one of the partial pressures that is 3 times larger than the other? Well, not 1 plus 7. 7 is not 3 times bigger than 1. What about 2 plus 6? 6 is 3 times as large as 2. So that must be correct. So the partial pressure of one of the gases must be 2 ATM. The partial pressure of the other gas must be 6 ATM. Go ahead and review your notes a few more times. Check over these problems. Watch the video again if you need more practice. Otherwise, log on to Exit Ticket on your Chromebook or iPod, and go ahead and complete the questions for review.